but it is quite important, I find, to just set the scene a little bit. Some of the material in this section, in the first section, you might have seen before or have a good understanding of. Please bear with me. I just want to kind of relate the topic and why there is such an urgent drive for net zero buildings, net zero precincts, etc. Then the concept of net zero water, we'll discuss that in a bit more detail, understand why it was born, what the definition is, specifically in the context of the Green Building Council of South Africa's net zero rating tool, and what the objectives of that tool are, a couple of pathways and strategies that perhaps could be useful in all of your work. Then we'll discuss my case study that we've worked on some years ago, and we'll also cover a bit of a demonstration of a very useful tool that the GBCSA has authored that can help a project really find a good approach to water balance on a development. Okay, so with no further ado, we'll be jumping straight in. If my slides were to advance, where's the button? There it is. Okay, so I think many of you will be more than familiar with the state of the climate crisis. Let's talk briefly at first about global temperatures. So this graph demonstrates, which is based on data from the National Center for Environmental Information out of the US, that we are facing a world of accelerated surface temperatures. Up until 2023, there were two tied hottest years. That was 2020 and 2016, but last year, unfortunately, shut the lights out again, as you can see in the graph, quite considerably exceeding the previous records. All of this, the science is quite overwhelmingly pointing in the same direction, that it is as a result of human influence. And as a result of human influence, I believe personally that it is also under human influence or within our control to mitigate this and adapt to the new normal. So moving on to a little bit more focused to our region, you can see on the left-hand side that there's some projections of what will happen to annual rainfall, which is often very closely linked to temperatures, which you see on the right-hand side. So suffice to say that Africa will get hotter and also mostly drier, specifically in our region in Southern Africa. And then bringing that a little bit closer to the topic of today, which is water. Obviously, we have seen that in the Cape quite pronounced a few years ago. One wouldn't think now, I'm Cape Town based, one wouldn't think with the recent rains that we still live in a water constrained region, and that we'll soon be facing heavy water stress, but it remains very true, as also can be seen by this image over here. Southern Africa and also our colleagues in Northern Africa will face the brunt of water stress in Africa at extremely high, which indicates above 80%, which is the ratio of human water demand versus water availability. So quite dire projections for North and South Africa. Then zooming in a little bit on water scarcity, a couple of interesting metrics that I have found in my research leading up to preparing for this webinar. It's projected that about 14 of the world's 20 megacities will be experiencing water scarcity or drought conditions in the upcoming decades. Further, also quite a shocking statistic, over 2 billion people live in countries where water supply is inadequate. Half of the world's population could be living in areas facing water scarcity as early as 2025. So that's next year, half of the population, that's roughly 4 billion people. Already some 700 million people could be displaced by intense water scarcity by 2030. And then 10 years from that, by 2040, roughly 1 in 4 children worldwide will be living in areas of extreme high water stress. So not great statistics, and apologies for that doom and gloom. I'm almost done, not quite yet. So here's a couple of water challenges of the water crisis globally. If we start in the top left, 40%, there's a 40% gap between global water supply and water demand projected by 2030. linked to obviously a population increase and water resources dwindling or being polluted or otherwise constrained. Then moving to the top right, about a quarter of the global population does not have access to safe potable water. Emphasis there on safe. It's not necessarily always about the quantity of water. It's also very much about the quality and the equity around that. So universal access to clean, fresh water is one of the main challenges that societies face in our current century, and then threatening human health and hindering economic growth as a result. Moving down to the bottom right, 10% of global greenhouse gas emissions come from global water use, storage, and distribution. So quite important to understand the nexus where energy and water meets. So that would include pumping, that would include water treatment, wastewater treatment, and the like. So just zooming in there, greenhouse gas emissions are generated by supplying water due to energy requirements for pumping, for treating, as I said, desalination, obviously, as we know, very very energy intensive distribution and waste management practices and processes. And then last but not least here, 90% of natural disasters are water related. So bringing home the kind of susceptibility that we are facing to water crisis related to, natural disasters related to water. So the increase in extreme weather events is having a global effect, but vulnerable communities are at higher risk. Okay, quite heavy. So as I say, don't want to leave you with doom and gloom. Hope is on the way. Please bear with me. We I think are all quite familiar with the United Nations Sustainable Development Goals, and the one that's most relevant to today's conversation is goal number 6, clean water and sanitation for all is the goal. There's a number of things that can be done in that realm. There's quite a lot of detail that the UN is working on and has been publishing. So I do encourage all of you to take a closer look there, but I just want to really kind of juxtapose that goal in the conversation about water stress to really highlight for the rest of this morning why the topic is so important. So related to water stress, food is obviously a key point, because 70% of all freshwater withdrawals are used by the agricultural sector. Then also, obviously, water is vital in cities and industries. Some statistics say 55% increase in global water demand, and we will be facing that by 2050, and that'll be most pronounced in cities. Water and energy, we already briefly mentioned it a short while ago. About 15% of freshwater withdrawals globally are for the production of electricity, and they are inextricably linked. And then ecosystems, there's about an estimated $20 trillion lost per year in ecosystem services due to the pollution and change in land use, all also linked back to water. So there's another row of statistics there for you to read if you so choose, but suffice it to say that we have a monumental goal that the UN SDGs is setting for us in a climate of water stress and a crisis. Okay, I just wanted to briefly change pace a little bit and not just talk about water availability, but also what we're doing, surface water availability, but also talking a little bit about what we're doing perhaps below the ground. So talking about water basins and aquifers and the resulting bigger picture, the water cycle. I think that most of us learned in geography in school, or at least I did, is obviously quite interesting, you know, moving from precipitation, runoff, extraction to the ocean, evaporation and back, but oftentimes overlook what that actually means in terms of infiltration into aquifers and then human extraction from those aquifers, and that those cycles actually are much slower and much less known than what is happening on the surface and with precipitation. So really important to also keep that in mind when we talk about the responsible use of water, and that it's not as simple as, oh, okay, our surface water is drying out and the dams are drying out, let's extract from underground. So a couple of points here. In many large urban nodes, water supply to residents and industries relies heavily on groundwater. That's already the case, especially in many urban centers where the population is so dense that surface water is not sufficient anymore, especially during drought period. Responses, we also saw that in the Western Cape a few years ago when Day Zero was approaching, more and more boreholes were sunk in backyards and around factories and everywhere really, to try and buffer the individual or the organization from the potentially looming drying taps. Then it's quite obvious, but I'm quoting this from one of the sources here, which I've also listed. Excessive groundwater withdrawals can cause groundwater levels to decline. I think that's quite obvious. We understand that now, but that can have some unforeseen consequences. It might, if you're close to saltwater sources like lakes or the ocean, obviously, it could result in seawater intrusion, which can have very long-term, very dire effects on continued use of groundwater. It can result in land subsidence, it can result in stream flow depletion and wells running dry. And then an interesting statistics, rapid groundwater decline, which means in excess of 0.5 meter per year, is somewhat widespread, especially in arid crop-producing areas. And they have accelerated in recent decades. About 30%, excuse me, of the world's aquifers, this acceleration has been felt or observed. And there is a little bit of hope here as well, that trend reversal in specific cases has been found following targeted policy changes and effective interventions. So quite an interesting study, where I also sourced the graphic on the right-hand side, where the linkage has been made between effective, as I say, policy or effective interventions and the recharge and reversal of the aquifers has been measured. So that's quite encouraging, that it is within our control to learn from mistakes of the past, learn what effective measures can be done, what effective policy changes should be implemented, and reverse these quite prolific trends. So yeah, this in the graphic, you can see a zoom in on a couple of areas where it's particularly pronounced, but yeah, the reds are concerning trend and the blues are encouraging trends. So even in regions, if you look at the top right image, which I right now forget where that is, but in a region which is mostly oranges and reds, a depletion of the groundwater, there can also be adjacent to that recharging, indicating that work is underway. Okay, I'm going to pause at this moment and just see if anyone has any commentary, any questions, any perspectives that they want to share. This is the end of the kind of scene setting section, so seems like a good time to just pause and see if anyone has anything to add. I see, Kelvin, you asked if the slides and the recording will be available after the session. I'd like to ask Gretchen or Tumeka to confirm that, but I believe, yes, it will be. Gretchen, is that true?
Hi, Andre. We are sharing resources with the delegates, but it will not include the recording.
Ah, okay. But the slide pack, I presume, just to confirm?
Correct.
Okay, thank you. Kelvin, there's that answer. That was a fairly easy one. Any other questions from anyone in the audience at this stage? Does anyone have any other stats to share? Any concerns that they've observed, media that they've read, that they wanted to bring into the conversation now? Brian, thank you. Let me just read your questions. How do we define sustainable resource? As mentioned in the last slide, very good question. If I may, I'm not going to answer that right now because I will be covering that at a later stage in the presentation. I'll be linking that question, or the answer to that question, directly to the definitions that the Green Building Council has developed for environmentally sustainable water sources. And also we'll be discussing a couple of nuances and perhaps even open up some critique on where that is at the moment, because the council has developed these as a starting point. They have been refined over time as projects are coming in, but they still are open for more feedback, for more critique, and for more amendments to make sure that we navigate this journey collectively as responsibly as possible, and also develop the tool and refine the tools to respond to what industry is coming up with, what policy is coming up with. So, Brian, if you can hang tight a little bit longer, that question I think will be answered, and please then also weigh in on your view of those definitions. Does anyone else have any questions? Okay, it seems that we are good on the question front. Thank you for those 2 questions so far. Okay, so moving into the net zero realm, and the language in the green building industry has advanced a little bit from when I first entered this industry 14 years ago or so, where the focus was on reducing our impact. It is now increasingly shifting to the likes of net zero, which is redressing impact all the way to no further impact, minimizing impact all the way to no impact, and then also at the same time linking it to the conversation of net positive, which is redressing impact, and actually, in the case of water, making more potable alternative waters available than the projects, the precincts, the building itself uses. So there is a shift in industry. There has been over the last 10 years, quite pronounced, and it's very exciting to be in that space and to work on some of those projects, because that's really where we have to head. So it is intended as a bridge in the journey to transforming the built environment from status quo to doing better, to really taking accountability for one's impact, and as I say, either completely eliminating impact or even better, redressing it. So it doesn't just, for now, the slide at least doesn't just talk about the net zero landscape, but talks about net zero water landscape, but talks about net zero in a wider picture. Oftentimes that topic first and foremost focuses actually on carbon, which has historically been the more talked about topic, and hence also the statistic here at the bottom. If we in South Africa are to make our goal of all buildings being built as or retrofitted to a net zero status by 2050, we should be seeing about 20 new buildings and retrofits confirmed as net zero every day. So that is quite a tall order, obviously, and we're nowhere near that at this point in time. But hopefully sessions like this will start paving the way for more and more individuals in their role of responsibilities, organizations, developers, and the like, bringing about best practice, and also wherever possible, taking the steps to certify buildings as net zero, in the hope to start creating more precedent, to start creating more case studies for others to learn from, and thereby also living up to what the Green Building Council is aiming to achieve by really advocating on this topic, by training on this topic, and by certifying projects as well. So that's really what the tool is aimed for. You can see those 3 pillars at the bottom of the slide. And yeah, this scheme that we're talking about here, this net zero rating scheme, aims to award projects which go beyond the partial reductions recognized in the other green building tools, and not just of the council, but globally. That's where the various green building councils around the world were at up until quite recently. So this tool specifically aims to award going above that. It supports projects to take the initiative to reach an endpoint of completely neutralizing, or even, as I mentioned just now, positively redressing their carbon emissions, their water consumption, their solid waste to landfill, and their negative ecological impacts. So those are the 4 certification pillars that are available, and either all of them or any one of them is available, or I guess also 2 and 3 could be available for certification on individual projects. Yes, so, wait, before I move on, I also just wanted to briefly mention that this tool can exist in isolation. So one can pursue, apply and certify a project only with net zero, as I mentioned, 1 or up to 4 of those pillars. One can also combine that with most of the other Green Star and Green Building Council's rating tools that are available, the new build suite of tools, the existing building performance tool, even the precinct tool, and also the EDGE rating system can be combined with the net zero certification. If the project is on a journey on more responsible green building practices throughout, one of those metrics in the project can be exemplified by elevating it to net zero or net positive status. Good, I hope that makes sense. And just wanted to briefly pause to see if anyone's got any questions where this rating tool fits in and what it aims to do. I'm going to slowly sip some more of my coffee while we will hopefully think about some questions. Did I see someone unmute themselves? Not yet. Okay. So no questions. All clear so far. I am glad. I was a little bit worried because at 3 o'clock this morning, my cat decided it's breakfast time. So I had a bit of a disrupted sleep. So I'm glad that I'm able to articulate clearly. Good. Are we all still with me? Can I carry on? I just want to pause, and if it's not a question, if someone can just show me that you're all still with me, or that at least one person is still with me, some response would be great. Anyone got the courage to do so?
Yes, we're still together.
Great. A sign of life. I like it.
Yeah, we're here as well at LTV.
Excellent. Thank you, Brian. Thank you, Simpiwe. Appreciate that sign of life. Yeah, we should be so used to it now, you know, doing virtual webinars, virtual meetings, virtual everything really coming out of COVID. But I must admit it is still very useful when I see that there's someone on the other side of the line, and I really do encourage engagement and questions. Please keep that in mind. Okay, so having talked about the tool broadly, I want to now talk about what the specific section within the rating tool on water means. So there is a specific definition which I will just read out so that we can dwell on that. And then again, please feel free if you want to discuss anything to clarify. It's quite important that we understand this definition. The rating tool and also a fair bit of the rest of our conversation this morning will be focusing on that definition. So what is net zero water? Net zero and net positive water, as per so extracted out of the net zero technical manual, it defines it as a building that is designed, constructed and operated to greatly reduce total water consumption and then use harvested, recycled and reused water such that the amounts of water consumed is the same as the amounts of water that is produced. So that would demonstrate a net zero building. Or if the water recycled/produced is greater than the water consumed, which would demonstrate a net positive building. And then just a disclaimer there, or adding on, it's important to note that all water produced by the project must be reused. So we can't just produce excess water and discard that in the hope that that would make up for irresponsible or excessive use elsewhere. So if we try and visualize that graphically, the bottom left, just get the laser pointer going. The orange bar is the kiloliters of water that is consumed in a building, in a precinct, and that must equate the amount of water that is produced. And that defines a net zero building, I think, quite obvious, hopefully. And then a net positive building, the amount of water consumed is less than the amount of water that is produced. And as I mentioned, we can't just have the ability to produce more. We actually have to utilize that efficiently, or effectively rather, in order to be recognized as net positive. Okay, I'm going to pause, and I'm hopefully going to hear from some of you with questions on what this actually means, and how we could go about this, because it is tricky, if I may say so. So, yeah, Simpiwe, I think you're unmuted. Please go ahead.
André, hi, it's Brian here, sitting with Simpiwe from L2D.
Oh.
What is the most effective mechanisms to achieve this in the South African context? And I think that's the key thing is that, you know, we've got our own circumstances in South Africa, and even within jurisdictions in South Africa, you know, a net zero solution in Durban or Joburg might be very different to Cape Town. What are realistic mechanisms of kind of getting to this point?
Yeah, thanks, Brian. Good question.
I mean, we're trying to drive down our water consumption as much as possible. We're doing things like replacing air conditioning equipment with air-cooled systems as opposed to water-cooled systems, and that'll take us off. Our water consumption will be reduced by quite significant amounts, you know, up to about 20% from doing that. And I think we're trying to do a lot more work around understanding our usage with smart metering and metering audits and that kind of stuff. But on what do we do on the other side in terms of supplying that to meaningfully get us there?
Yeah, great. So we'll talk about a couple of practical steps that can be taken. Just a disclaimer, there are no silver bullets, and every project is unique and needs a focused investigation. So what I'm not trying to do today is give you a blueprint of interventions to roll out, but rather pathways and modalities to explore, and also a hierarchy, perhaps. We'll talk about that shortly, and where to focus first. And you mentioned a couple of really good things. I think you touched on reduction, you touched on measuring, so understanding your consumption. Those are very valuable and very valid interventions, and I'll be locating them a little bit later in the slides in a bit of a hierarchy, and amidst some other interventions that could be pursued. So, great question. I see your hand is up again. Please go ahead.
Yeah, just to add, it's Simpiwe here, André. Just to add what Brian has just said, are there any mechanisms also on demand management that we can do? And also, what are the policy restrictions to what Brian has also asked?
So demand management, I interpret as really a pathway to greater efficiency. And one of the ones Brian already mentioned, it's the air conditioners, upgrading those from water-cooled to air-cooled. There's various other interventions that typically come up in a suite of best practice green building water interventions. So we'll cover a bit of that. Yeah, so absolutely. I think some of those questions will be answered. Keep track of whether you think that I've done it justice, your questions justice, as we move along. Thank you. Any other questions? Any questions on this definition? Any questions on the bar graphs at the bottom? It is currently, it looks, at least this is my interpretation when I started on this journey of unpacking the net zero tools more several years ago and pursuing the first few projects. It looks at face value quite simple. You know, make the left equal to the right and we've got net zero, or make the right greater than the left and we've got net positive. Sounds great. But practically, it actually isn't all that easy. And even from a definition point of view, I'd venture to say that we have a more difficult time doing this on water than we do even with energy or carbon. And I'll get into that shortly. I don't know if any of you agree with me or differ with me, but I just would like to keep front of mind that this is indeed a very challenging thing to get right, to achieve a net zero outcome, is indeed really that. It's about the outcome, and in the end, the proof is in the pudding. So for me, the very simplest way of visualizing this is when we're done with a net zero project, once it's in operation, in essence, our water bill from the municipality should be R0 on that line item. And that's really where one demonstrates that that's the outcome. There are different ways of getting about it, and that isn't always exactly what needs to happen. And there's other pathways we could consider pursuing. But for the time being, until those are all resolved, that's more or less what we have to do, because let me kind of preempt the upcoming conversation. But pathways of offsite solutions, or even offsetting, like we know them from the carbon world, there aren't any practical ones, as far as I understand, in the water world at this point in time. So with that, not seeing any further questions.
There's a question in the chat
there is a
from
question.
Adil.
Thank you, Gretchen. With borehole usage you mentioned earlier, how could that become sustainable to offset net zero / net positive? Adil, I thank you for your question. I would also like to suggest that we cover that specifically when we get to the section on the definitions of environmentally responsible or sustainable water sources. So Gretchen, if you can leave that question up, I'll try and address that specifically when we get to that section. But it's a very good point, and there is nuances around what is considered a sustainable source of water, and may we use that responsibly, and may we use that for a certification. Okay, good. So I'll get back to you on that, Adil. Thank you. Great. Then I just wanted to give a bit more context on what the tool is, the certification is available for. And as I alluded to it earlier, it's available for new buildings, which includes also major refurbishments at the design or at an as-built stage. And they can achieve a certification for modeled level 2 net zero or net positive water, or existing buildings, existing tenancies, or existing precincts that are in operation can also pursue a certification, but these can only pursue a measured certification. What that means, we have to measure our actual potable water consumption. That has to be 0, or we have to produce more alternatives, then we consume, and that would be positive. So the image on the bottom right, it demonstrates that. And next is the definition of the different levels. So I'll get to that shortly. I should have probably done that the other way around, come to think of it. Level 1, which is the base building consumption, is not available for any of the certifications. Level 2, which is the base building and the occupant consumption, is available for net zero in new build and existing, and net positive in new build and existing. So just keep that in mind when we talk about the 5 different levels that have been identified, of which only the first 2 are effectively in use for now. Okay, so we'll get back to this one. Apologies for not having defined the levels yet. What I also want to cover as we dive deeper is the so-called pathways that the rating tool identifies and outlines. So the first one is even in the definition. It really alludes to water efficiency, demand-side management, as we spoke about just now, and many of the practical interventions that we are perhaps familiar with from tap aerators and from reducing our consumption. That all sits in this pathway 1. Then the next tier of this kind of inverted pyramid is pathway 2, which speaks to on-site water capture and reuse. And here the definition will come back to us of what is a sustainable, environmentally responsible alternative water source. And we'll get to that detail shortly. So first efficiency, then on-site alternatives. And if we want to pursue in pathways 3 and 4, we have to do a certain minimum of this in the tool. There's a checklist. We have to cover 75% of that checklist if we want to be allowed for pathways 3 and 4. That checklist is good to consult in any case, because it gives a couple of practical aspects, a couple of practical interventions to check. Have you done these things? But that brings me to that difficulty that I alluded to. In the context of carbon, briefly, it is quite easily visualized what pathway 3 would be. Offsite solutions, I think more and more the conversation about energy wheeling has been coming up in recent years. For example, a big developer or a big property owner, real estate investment trust, for example, could have a contract with a solar farm in the Karoo through some kind of power purchasing agreement and wheeling agreements through the national grid to their various properties across the country. That is not just theoretically possible, that is also practically possible. The regulations are in place in an increasing number of municipalities, and is becoming a useful mechanism to reduce one's impact in the carbon world or energy world with off-site solutions. Some building typologies just simply are more energy intensive than they have roof space for producing one's on-site energy. But in the water world of things, what does this actually mean? And I'm not going to try and even pose any questions right now because I'd like to answers right now because I'd like to leave this an open question for conversation. And I'll pause just now after I've discussed pathway 4. So similarly, I'm gonna sidestep quickly to the world of carbon. Carbon offsets is a very well-known mechanism. There can be a qualifying carbon offsetting project that generates carbon offsets by sequestering or reducing carbon emissions. We know various types of projects in the country and globally, from reforestation projects, from projects on recycling, projects on composting, projects regarding cooking mechanisms in often even rural areas. So there's a number of different kinds of projects which generate so-called carbon credits, where a project that wants to achieve a net zero or net positive carbon outcome can purchase those carbon credits. Okay, so that is quite established. It's been tried and tested. There's a fairly, relative to water, there's a large number of net zero carbon projects that the Green Building Council has certified, and some of them utilize pathways 3 and 4 in the carbon world. So offsite solutions or carbon offsetting. Fairly easy. In the water realm, again, an open question. What is a water offset? Do those exist? Can you buy them anywhere? Can you visualize even what a project, a water offsetting project would be? And at this point, I'm going to pause and just see if anyone has got any ideas. What could be a water offsite solution? What could be a water offset? Anyone want to hazard an idea? Hazard a guess?
Hi, Andre.
Yes,
I think
James.
I think having a rainwater capture system installed on a off-site facility could qualify as a off-site. So, say you purchase rainwater harvesting tanks and you install it on a different site, that could qualify or speak towards your off-site solution, perhaps.
Quite right. Theoretically, that sounds simple enough. Practically, not to try and undermine your idea, because I think there's many good merits there and we need to unpack that more. But practically, there are some obstacles in the way here. In most municipalities, I've not studied all of them, so I'm not going to try and hazard a statement like all municipalities, but generally it is quite controlled what one can do with services being transferred across urban boundaries, across property boundaries that aren't under the control of the municipality, or in the case of power, the national grid. So Eskom and the municipalities are allowed to centrally produce power and potable water and distribute that through a region, whereas you as an organization, as an individual, as a property owner, as a developer, don't have the same liberties and would face quite a bit of regulatory obstacles to try and do so. So that is indeed quite tricky. There are a couple of solutions in private public partnerships that are starting to emerge. So, for example, some wastewater treatment works produce treated grey water. There's a good case in Cape Town. The Potsdam Waterworks circulates or distributes treated grey water to areas like Century City, which where properties there can utilize that for non-potable uses like irrigation, toilet flushing, and the like. So that would be an offsite solution. And similarly, I would like to encourage everyone to explore how we can unlock more of those, especially where we don't need to be contingent on a public entity providing that water. That plant, unfortunately, has been marred with various quality concerns and continuity or consistency concerns as well, where some months that supply is there, and other months all of a sudden a building might be left without that grey water for toilet flushing, and then has to scramble to make an alternative solution. So I encourage more research, investment, investigation, navigating the regulatory difficulties on that front. But yes, that is indeed theoretically a solution there. Anyone else got any ideas on pathways 3 or 4?
So I have something possibly to think about. It's less of a this is a suggestion and more of a this is a query to ponder. If you think about the case of the water hub in Franschhoek, there they've rehabilitated an old waterworks facility, and they are testing the removal of pollutants from a river that runs past an informal settlement with nature-based solutions using constructed wetlands and the like. So the question is, if you contribute to cleaning up a river, it's not producing more water as such, but it is making the environment cleaner. So I'm just trying, I don't see it as net positive. I'm just trying to see if that would fit into the nexus of things that might be able to be motivated. Then the other one that sort of comes to mind is maybe recharging the groundwater, which is but that's very difficult to quantify. And you were talking about groundwater in your introduction. Yeah, so those are two things to maybe debate a little bit or think about.
Thank you, Peter. Does anyone have any responses to those two ideas? I do, if no one else wants to. Yeah, great ideas, and speak on a similar nature to some theoretical ideas I also have on water offsets. I would argue that the first example that you mentioned indeed makes a case for something akin to a water offset, with a whole lot of NBs or asterisks for disclaimers there. Because what it does, it makes available more water of safe quality, or if that's the outcome, then I would support it. Yes, quantity of water is not, as I mentioned, always the only metric. It's also quantity with an understanding for the quality. So if that project is unlocking quantities of safe water further downstream, then indeed, to me, that would be a very worthwhile project to pursue and see if it can be supported and unlocked in this world. The asterisks that I mentioned, the disclaimers, I'd just like to, at this stage, briefly insert into the conversation the thinking about time and place in the world of water, where that is not nearly as critical in the world of carbon. Once again, it seems like the guys in the carbon worlds have an easier time, and for some reason, thank you to Gretchen and Jamaica, I got the difficult one with net zero water, but happy to try and navigate that as best as I can. So the difficulty here, Peter, to respond, is if we unlock greater cleaned water in one water basin, I would warn against using that or aiming to use that as a water offset in a different region or in a very different time. So carbon, again, I'm jumping between carbon and water to just demonstrate the differences. A kilogram or a ton of CO2 sequestered or avoided is reducing the impact in the atmosphere and is more or less free of national boundaries, free of something akin to water basins, because that covers the globe as a whole, and we are racing against global climate change issues, which are brought about by atmospheric concentrations of carbon. So that allows for a carbon project in one region to be used to offset carbon impact on a project in a different region. Personally, on that note, I typically always advocate for a carbon offsetting project as close as possible to the site, so to also have regional benefits and socioeconomic regional benefits and the like, but it is from a carbon point of view less important than from other aspect point of view. Okay, where with water, the benefit is directly in a certain water basin, and if we extract from a different water basin or aquifer with the project that we're trying to offset, it'll have a negative impact, and perhaps even irreversible negative impact if we, for example, consider what I mentioned earlier on the saltwater ingress that the offsetting does not address. So I briefly just wanted to inject that, see if anyone has got any thoughts on that and responses to that. But that does add a layer of complexity, and also in the resources section right at the end, which I encourage all of you to take a look at, I linked a paper or a note really from the WWF where they talk about this topic at some more length and the difficulties between both temporal and also geographic importance in the conversation about offsetting of water impact. Any responses, Peter, to those thoughts and those notes, or anyone else really? Yeah, Peter, go ahead.
Yeah, so one of the things that came up in another seminar was that when we recharge, we do rainwater borehole recharging, we have no way of knowing if the water we're putting into the borehole is going into the same water aquifer that we're drawing out of. And I haven't fully understood the geotechnical stuff around that. And that speaks to your point about geographic disparity or changes, spatial disparity in where the water is going, and spatial disconnect. So it would be nice to be able to interrogate that a bit more and have a greater understanding of if we are recharging boreholes with, say, treated grey water or whatever the case may be, rainwater that's captured, is there a way, and we're putting more into it than we're drawing out and essentially using it as a storage vessel, then what tests do we have to do to determine that that water is going into the same aquifer that we're drawing out of?
Yeah, because you're quite right. Even if that happens on site, it is not always a given unless you get your depths right, and the depth on one side of your site is also not necessarily where the water table or the same aquifers at the same depth on the other side of the site, because there's so much layer works in the geology that could have different aquifers that you're tapping into or out of at different heights. So quite right, it's complex. I don't have any solutions there. I just wanted to sensitize all of you. So thank you for bringing up those ideas, Peter. Wanted to sensitize all of you to the complexities around that, and that there is a bit more perhaps research that needs to be done, both at a bigger scale, but also at each project scale, before one simply assumes that, that we can just start drilling or we can just start recharging aquifers. It is complex. The Green Building Council has not been able to articulate a perfect guidance around that. They admit that, and it is in some of their public notes as well, but they very much invite projects to take the plunge and to investigate and use their project as a case study to develop knowledge around this and see what the responsible thing is to do. And do we need a hydrocensus to understand this issue that Peter described more, or is that too much burden on a project? So those questions are still open, and I think it's important in a discussion in a session like today to really highlight the difficulties as much as any potential solutions we have. Okay, so briefly talking about a couple of other ideas that actually only one remaining one that I have here. I could also visualize, for example, large-scale alien tree clearing projects that unlock, avoid those often very thirsty species consumption from the groundwater and unlock that water back into the aquifers and hopefully then back into streams and rivers and the like, and make hopefully measurable quantities of water available, which could potentially, at least theoretically, be certified and converted into a water offset. But again, the time and space complexity is important here. I don't deem it responsible. This hasn't been developed or formally communicated or even begun to be articulated, but I don't see it as responsible as doing something like that, where someone manages a project somewhere in KZN for such a water offset to be used at a project in Cape Town, for argument's sake. I don't think that's responsible because of those nuances that we just described. But those kind of projects, at least, are theoretically possible, and in my mind, there is a case to be made that can be used in the same region, the same water basin, the same aquifers as offsets. Okay. Yeah, very interesting conversation. I see, James, your hand is up, and then...
Okay.
Sorry, Andrew, just one more idea I just had. How about offering to, if I've heard a lot of statistics about municipal pipe work needing upgrading and a lot of potable water being lost through distribution. So I was wondering, how about a project then offering to repair a section of the supply pipe work if it's found to be leaky, and then they can perhaps measure, I don't know if they can necessarily quantify exactly how much water is lost through the process, but it would be quite interesting to say that the project then sponsors replacement of the supply infrastructure as a way to save some of the water that's being supplied to them.
Yeah, a very interesting point, James. Thank you. I haven't thought about it in that way. I would love to see all of the leaky pipes in South Africa be replaced. The amount of water loss, or so-called non-revenue water, which alludes to leaky pipes, but also water theft and the like, is astronomically high. Perfect numbers don't exist, but I've heard them as high as 40% on the national average, which is scary. I think other data exist around that, but even if it's anywhere close to 40%, that is a scary number and makes for a good point or justification to your point. Why don't we make a project out of that, see if that can also be converted into a water offset? That would take a little bit the difficulty of the water basin conversation out, because by that time that water has already been extracted. It is in a most likely urban distribution network and is made available where it was previously lost. So I do think there's a strong argument there for water offsets, and perhaps that's worth exploring further with the likes of Rand Water, who obviously are bulk supplier of water, supplying many of the municipalities, well, in Gauteng and surrounding provinces. Yeah, absolutely. I think that's a very good idea, and perhaps something that the Green Building Council can take to those parties. I'll make a note of that. Thank you. Brian, I think you were also unmuted and wanted to say something.
Yes, I wanted to just ask, or maybe ask how practical it is. Let's say for a building like the one on the slide right now, and let's say if we're going to treat, if that building was going to treat its own water, and let's say innovate a way to just treat the building's water. I don't know, within the as part of its design and its construction, right? And that action in having the building like sustain itself, can that be considered like that action as a water offset? Like, let's say we are building that water treatment plant for our building. Can that action alone just be considered as a water offset?
No. As far as I understand the definitions, it cannot, because that is on-site solutions in pathways 1 and 2. So efficiency of the project and on-site water capture, presumably the likes of rainwater or recycling systems like grey or black water treatment. That would fall in the first two pathways, and offsets is where similar to carbon, where the impact is sequestered or avoided elsewhere, and you get the environmental benefit of that, or the environmental claims of that rather. Yeah, good. I think I saw some questions in the Q&A box. Let me just call those up. Obaid, do you want to read this out or articulate your question? Attenuation ponds shared between sites, would this be regarded as an off-site solution? If it is not on any one urban, but rather sits between multiple urban, is that what you're proposing here?
Yes. Yeah. Hi, everybody. So I was proposing that. Of course, it kind of differs from site to site and depending on the area that the project's kind of working on. But if, for example, there is the ability to set up an attenuation pond for rainwater collection or whatever mechanism they intend on installing, and it is a partnership with a third party, would it then be regarded as an off-site solution, or would that be an on-site water capture and reuse? So it'd be very similar, I guess, to the Potsdam example, but instead of it being a municipal infrastructure, it would be a private partnership, basically.
I think it can qualify. Obviously, it's about what that water gets used to and then how you get it back to your site if you want to claim it as an off-site solution. But theoretically, yes, if that attenuation pond stores rainwater and filters it and then pumps it back to the site, noting the difficulties about services crossing urban boundaries. If that's been resolved with the municipalities to unlock that, and that partnership is making the water available for use on a specific project, your project, then I believe that could be a off-site solution, absolutely. But you have to have that back on your site as a source of alternative water is the crux. So you can't just centrally attenuate that water, treat it, and then it's available for someone else's use. That wouldn't be an off-site solution. You need that water back for yourself. Okay. Any other comments or questions on our inverted pyramid? Oh, there was another question. If it's run by a third party. Okay, thanks, Abed. Great, some nice ideas. Good discussion. I think there's certainly opportunities. I've made a note of a few. I'm going to encourage the Green Building Council to engage with Rand Water. I think perhaps the most obvious case to see if there's a project there and other options to explore. It would be great if there's a bit of a database forming of potential projects that a developing project that wants to pursue a rating can further engage with and see if it meets their needs. Okay, any other comments or questions? Okay, then the overdue next slide is just the different levels. Noting that currently only levels 1 and levels 2 are in use because the further levels are not well enough understood. There's not good data on quantifying them. But in essence, the levels follow also the definitions of the levels in carbon. So the first one is the base building consumption. In essence, what do building systems consume without the overlay of what the occupants do? And that's why I'll get back to the previous slide just now, why level 1 on its own is not available for certification, because it is very difficult to begin to quantify or even measure how base building systems consume water without the influence of occupants. Level 2 then is the base building plus occupant consumption, which would include our typical water consumption through the taps, through showers, through toilet flushing, all kind of internal potable use, would include irrigation, would include also for air conditioning and evaporative cooling, systems, all of that water is included in there. Then embodied consumption is a bit of a trickier one. That's really the water consumption is associated with extraction and processing of raw materials, transport of materials and equipment to the site, the construction and installation of building structure systems and equipment. For example, the mixing of concrete uses a whole lot of water just in that before it is allowed to cure. And then for informational purposes, as I mentioned, this level is not yet available. Data is difficult to come by, and as we just discussed, levels 1 and 2 are difficult and complex enough. The Green Building Council doesn't yet open this up for certification, but encourages robust conversations and deliberations on that as well. Level 4 is any consumption associated with renovations, so water consumed with substantial changes to the building. That usually involves external energy using equipment and building professionals, right? So if there's a big renovation undertaken, then indeed what is level 3 for the first build, it would be deemed as the water that we predict would be consumed in a renovation. Level 5, anything associated with the end of life of a project, so deconstruction and from demolition works on site, if water is needed there, but also transport during this process, and those resulting from reuse, recycle, and final disposal of waste materials. And just a reminder quickly, level 4 and level 5 are not yet available for use in the rating tool. Okay, so understanding that a little bit better, I'm just going to come back to this slide, and perhaps, or hopefully by now, it becomes clear why level 1 isn't available, why level 2 is where we're focusing at this point in time, and levels 3, 4, and 5 are omitted here because they're not well enough understood, data isn't available, and the complexities aren't fully figured out yet, and thus not available in the rating pool. Does that make sense? In particular, does it make sense why level 1 is not available?
Yeah, André, I think it's clear. Thanks.
Great. James, you had a question in the Q&A box. I would imagine lockdown would have provided good data to try and quantify level 1 base building consumption. That's very true. Good point. I just fear that at that point in time, everyone was panicked enough about what COVID was, the risk that COVID presented, that measuring and taking note of the water consumed in base buildings with no one in them, I suspect was the least on building managers' worries. So I don't think it has been, that data hasn't, as far as I'm aware, hasn't really been extracted and analyzed in that way. But it's a good point. Perhaps there is something to be done there. Although looking at where the tool is positioned and the stance that the Green Building Council has taken, I do think going forward, it is the most responsible thing to stick to the kind of tiering that it is at the moment and not allowing for level 1 projects on their own, especially because a building ignoring the occupants, the water consumption in a building ignoring the occupants is minimal and doesn't really mean much. It's much easier to quantify that difference in the case of carbon. Once again, they have an easier time there. So they have level 1 available for certification, where water doesn't. And I think the water consumption is inextricably linked between the building and the occupants. And therefore, in my mind, it makes sense to always kind of automatically arrive at a level 2 certification only. James, does that give some perspective? A good thought nonetheless, and could have been an interesting data science project, perhaps.
No, agree. Thanks, André.
Excellent. Okay. Anything else on the pathways, what's available for certification and the levels? Any questions there before we move on? We're looking for time. We have a break coming up in about 15 minutes. So I'm going to move on to the definition of the eco-friendly water sources. We had a number of questions really on this front. And we spoke a little bit about it. So I'm going to dive into a bit of detail here. Please feel free to ask any questions as we go through it. And also, as I say, please go ahead and challenge these definitions if you feel like you have a different opinion. It's quite important that we keep coming back to this. I spoke to one of the technical managers at the Green Builder Council leading up to this conversation, leading up to this conversation last week, I think we spoke. And again, he reminded me to really invite feedback on this and see if anyone has any thoughts, because it is nuanced and it is tricky, and we do want to communicate the current stance, but also, as I say, open doors up for being challenged then, so that we can advance the industry going forward. Okay, so the net zero rating tool itself, but also other tools in the stable at the Green Building Council have various definitions, and they are quite nuanced for good reasons of what environmentally sustainable water sources are. The aim there is to find the right balance between encouraging alternative water sources rather than municipal potable sources, but at the same time avoiding unforeseen or unwanted effects from irresponsibly using other sources. So municipal potable water, obvious, is not an environmentally sustainable or renewable water source. So that's why that's marked as no. River, dam, and lake extraction also not, and is usually the primary source of municipal water. Borehole and well extraction, typically not, or at least the current definitions deem it as not an environmentally sustainable water source. I have, however, made a little asterisk next to that after conversing with Dash to just again invite projects that want to challenge this, that want to explore this and see if there's an opportunity here. So that asterisk, what that means is the Green Building Council encourages innovative ways to recharge the water table if borehole water is being used. So that's a general encouragement. Some projects can't get away from the use of borehole water, for example. If they do so, there is an encouragement to consider recharging the water table, even if that doesn't in the end qualify as an environmentally sustainable water source. It's still best practice. And at the same time, the Green Building Council also encourages projects to conduct a hydrocensus and a water balance when using these sources, even if that doesn't mean there is a net zero outcome possible, because it currently isn't interpreted or defined as an environmentally sustainable source. Desalination, at this point in time, the Green Building Council doesn't deem it as a environmentally sustainable water source. The conditions attached to that I've currently marked with to be confirmed, because that hasn't been explored sufficiently yet. Perhaps there are some scenarios where the adverse effects of desalination can be sufficiently mitigated, and thus we allow for desalination water to be deemed as environmentally sustainable. So work in progress, or work still required here. It is currently no, without further unpacking and further justification. Simpiwe, you've got a question.
Yeah, thanks, Andre. I was just wondering, where can we capture rainwater on those sources?
Yes, great. The one right at the bottom. Is my pointer on? Yes, it is. So if you spot that down here, it is deemed as an environmentally sustainable water source. And just in terms of conditions, there's certain evidence of approval from the relevant authorities if they have any requirements there. And that must all be done. So in essence, the Green Building Council is saying, yes, it is a environmentally sustainable water source, but you have to meet all of the regulatory requirements, bylaws, etc., if it is to be used in a project for a net zero or net positive certification. Similarly, I'm going now from bottom up, grey or black water recycling systems, the same applies. Atmospheric water generating systems, also often called air to water, are equally deemed as environmentally sustainable. And in my mind, I've never used it on a project before. In my mind, the approvals would be probably less, but I've got no experience there, hence the evidence of approval where applicable. And generally, if anything is plumbed into a building's plumbing network, there are certain requirements the city of Cape Town at the height of the water crisis developed various ones there that we need to follow. I'm not sure where all the other municipalities stand, but there are requirements, and they become stricter and stricter, especially once we are integrated into the building's plumbing network. So some atmospheric water generators are standalone desktop devices. It extracts humidity from the air and fills a glass of water to oversimplify the functioning. That I think has no specific regulatory compliance requirements, but if it is a larger system and it is plumbed into the building's network, then please be aware there's other requirements. Okay, and then looking at the center of the table, here is one that kind of straddles between it is environmentally sustainable and maybe not. So there is some precedent, and actually the case study project that I'll be presenting a bit later makes use of this water source. So currently, it can be considered as environmentally sustainable. You note my language here, yes, but with conditions. So it has to meet those conditions before it can be deemed sustainable and used on a net zero project. So first of all, it needs to, or it triggers the requirement for that efficiency list that I mentioned. 75% of, I think there's 13 line items on that list, have to be met. And they speak to on-site water efficiency and on-site water solutions, alternative water solutions. There's a requirement for a water meter to be installed on that seepage water for management. So it also has to be for active and effective water management. It has to be connected to a management system. Can't just be a meter that no one ever reads. And there is a requirement for a balancing here, that the extraction volumes after certification project is implemented my typing is off there, apologies, to be equal or less to before. So there's a water balancing required. We can't just start extracting more from the seepage water than we did before. We'll get back to this nuance on the case study specifically and how that requirement was met. And then the project has to develop and commit to implementing a seepage water management plan that aims to avoid irresponsible extraction of seepage water, the ongoing monitoring and management of that water source, the adequate treating of that water source, etc., maintenance and all of that surrounding the use, and then provide evidence that all requirements regarding quality and various other municipal and regulatory requirements are complied with. So in essence, to summarize, ground seepage water, yes, but can be considered as environmentally sustainable source. Is that clear so far? And does everyone appreciate why these restrictions or requirements are placed on this source of groundwater seepage in particular? Say silence is golden. I'm not always 100% sure that's true. I suspect absence of comment to the contrary. I hope that everything's clear. Great. I'm just going back to Adil, to your question earlier with borehole usage. You mentioned how could that become sustainable to offset net zero net positive? Okay, so borehole, as I mentioned, currently not deemed as a sustainable water source. I differentiate borehole from groundwater seepage, so that could be the dewatering of basement parking, for example, as groundwater seepage, and differentiating from typically a vertical borehole for the sole purpose of extracting water out of the ground. So borehole typically not allowed, but open invitation from the council to start challenging that is really the short answer to your question, Fadi. I hope that clarifies.
Yeah, all good. Thanks, Andre.
Thank you, Adil. Okay, good. I think then we are done with this slide. I'm going to move on to the next, which there's two more that I want to cover before our break. Yeah, so on the slide, what I'm trying to convey here is, just to hide my view, there we go. what I'm trying to convey here is the context of where we are perhaps operating in the built environment. So supply chain, I talked about that earlier in the levels to some extent. Really, this is a bit of a rephrasing of the levels that the tool defines. But the context is really important to understand what is under our influence and what isn't. So supply chain would be level 3, really. The construction process in itself is also embedded and part of level 3. The building is levels 1 and 2. And then cities and communities, that's an interesting one. I'm just going to read this text here to illustrate. While citizens require direct water for basic needs, that would be levels 1 and 2. Such as drinking water, cooking and cleaning, our municipal utilities and services also require fresh water, and that's quite an interesting one. Urban centers often face problems related to insufficient infrastructure, water consumption and loss, wastewater management, and water drainage. That's harder to quantify, harder to manage, but is really also a big consumer of, potentially a big consumer of water, and particular to James's point earlier, water loss or non-revenue water would fall into this world. So good to keep an eye on the bigger picture and where we have influence, and typically, at least in my world, the built environment sector that we're active in, our biggest influence is currently here and focus is currently here. And then, oh, actually, this is the penultimate before our break. Also, just after having discussed the detail of the tool, I wanted to take a bit of a bigger view. So this is a graphic that I borrowed from the Atlanta Special Economic Zone and their material on their net zero water action plan. I find this very useful to just think about the various scales that we're talking about here and what happens at the various scales. So tapering down in this inverted pyramid, we can think about the influence and how we align and support the various actions at those scales. And so let's start with global. So there's global norms, there's global conventions, there's protocols, there's agreements, there's challenges and goals like the SDGs, the Water Resilience Coalition, the global conversation around water stewardship, and water stewardship as the use of water that is socially and culturally equitable, environmentally sustainable, and economically beneficial through, I'd say, multi-stakeholder inclusive processes that involves site and catchment-based actions. So water stewardship is a really important topic when we really think about responsible water use. Then coming to national level, national policies and programs, various acts like Espluma and NEMA, national water policies, national water resource strategies, green and blue drop, and those kind of initiatives that all inform on a national level responsible use of water. We're to regional, there's typically provincial and regional strategies, planning and agencies that have their role on various tiers as well. The city context also very important, and a site in particular, I think, has a responsibility to completely align with all initiatives at this level, plans, initiatives and strategies, bylaws, building regulations, wastewater treatment works, water reticulation, demand management, and supply security all become really pronounced at this level. And then at the precinct level in an industrial park, like the Atlanta Special Economic Zone is, but also other precincts and neighborhoods, focus becomes quite important at any guidelines of that precinct, the associated stormwater management and infiltration infrastructure, green building precinct guidelines, the Green Building Council of South Africa's Green Precinct tool has various guidelines and benefits here. And then there's some really exciting case studies of industrial parks that have done some great work that you're welcome to look into. On the building or factory or site level, here we talk about specific interventions, water saving devices, recycling programs, energy saving techniques and technologies, green building guidelines, regulations, water use and management. And then all the way down to individual, often overlooked. How can the individual fit into this hierarchy? What can they do It talks around what lifestyle or behavior choices, what products they consume, how they use water in our sites, and also what other products they kind of purchase and utilize on a day-to-day basis. Okay, I think that takes us to past. It does too, and hopefully the break, I think we said, is 10 minutes long. Is that right, Gretchen? 10 minutes, yes. So 10-minute
Yes,
comfort
thanks.
break. And we will resume with a couple of, now having set the scene at the various scales and tiers, understanding the net zero tool, we'll hopefully have set the scene with a couple of specific interventions that could be considered going forward. So with that, I thank you for your attention so far. I'll see you in 10 minutes and look forward to further robust conversation and engaging with you. See you shortly. Okay. Welcome back, everybody. Hope everyone's back with us. I have 1 or 2 thumbs up just to check that.
Yep, good to go.
Great. Okay, excellent. So just wanted to see if there were any questions and particularly any questions around this slide over here regarding water stewardship and an action plan that is informed by the scale of the interventions. Yeah, any questions, comments? Was it helpful? Is it too theoretical?
André, Brian here. Just how do we practically kind of bring this down without spending hundreds of hours trying to understand all the legislation and that? How do you? What's the kind of easiest way to make sure that you're complying with everything?
It is unfortunately one I can't give you a clear, direct answer on because it's so nuanced and so site-specific. But there are a couple of things, and maybe that's a good segue for the next slide, to start talking about a couple of practical interventions that can be done also at different tiers. So this is just a hierarchy of principles of water management, and then my next slide will be about just listing a couple of interventions to start thinking about. Compliance is unfortunately always a site-specific aspect to unpack, and there are a few things which trigger an investigation or a further analysis if that's needed. And I think maybe once we get to those, I'll just highlight, okay, at this stage, do all of these things without much thinking about any regulatory work as far as I understand. By no means am I trying to provide legal advice on the bylaws. But at least from my understanding, and then perhaps from here onwards, be cautious and just double check that with any compliance with regulations. So I'll get to that perhaps in the next slide if that's okay with you, Brian. Thank you for the question. Okay, so good to think about, or at least for me, I find it useful to think about a bit of a hierarchy of where to focus on for water management. Starting off with prevention. So avoiding the unnecessary use of water that considers the local needs and looks for opportunities to prevent using potable water sources for manufacturing, construction, operation, personal and potable water use, really, or water of all sources, but also personal use. Then I think it may have been you earlier, Brian, as well, that mentioned measuring. So very good to understand how much and where water is being used to help manage water loss and leakage as well. So this is vital at all tiers, from the level of around water, that is a huge water provider, to the municipalities that are water distributors, to a precinct or neighborhood, to the individual building, and then also within that building for major users of water within that building. For example, if it is a water-based heat rejection system, typically a big user, I would suggest submetering that. In the restrooms, I would suggest submetering that. If there's any kitchens, that could also be deemed a large water user, and good to submeter those kind of key areas and key water users, as well as any incoming water sources, measuring those, potable water or alternative water systems, so that one understands where are we using water, where's our water coming from, and can respond to any leaks or suspicious trends accordingly. Then reducing, prioritize on-site or local recycled water sources. This is here really talking about the efficient use of water during manufacturing and construction, and implement low-flow fittings and features for operation. So perhaps useful to just go back and differentiate a little bit. How can we avoid use by not doing certain things, and then how can we, in the reducing, use water more efficiently? Reusing different water sources. Rainwater is a good example, but also, as I mentioned earlier, grey and black water recycling systems are systems that can often quite effectively be used on a site basis. And then restoring, how can we do our part on a site basis to restore water back into natural systems. There's various techniques here: water-sensitive urban design, sustainable urban design on a bigger scale, even sustainable urban drainage systems, nature-based solutions. I think Peter mentioned that earlier for the example in Franschhoek, I think it was, and other similar methods. Then preparing for events of typically high, but also of very low water flows, so flooding, droughts, and the like, and also water treatment for potential use or final clean discharge without running the risk of polluting water sources and even downstream water uses. So the Vaal River is an often cited example where one municipality extracts and then there supplies potable water to the population, and then the wastewater treatment, once it's been treated to the regulatory standards, one hopes, it is discharged back into the river, and then downstream another municipality would abstract again and continue that cycle. So it's very important that each vantage point takes responsibility for their use and what they extracted, but also what they discharge back into natural water systems to not pollute those. Okay, so these are a couple of principles to consider, then going into some specific interventions. A water accounting structure. So this is on the analyze of consumption side. Water accounting structure, staff encouragement, and possible incentive programs to ensure responsible water use and behavior. Leak detection, we talked about that. Water metering and sub-metering installations, we also spoke about that. Then investigations and good record keeping, and also perhaps optimizing low pressure regulators to make sure that we don't have too high pressure in our systems, which could cause leaks, but would also increase the consumption or the flow rates out of certain faucets if it's unnecessarily high. Then one can reduce water consumption by installing low flow shower heads and taps, low flush and waterless toilets. So waterless toilets could be composting toilets, for example, waterless urinals, also moisture sensors and irrigation systems to only irrigate as and when and how much is needed, various water-saving appliances, and dual water systems. So that would be a potable water supply, but also a non-potable water supply for things like toilet flushing, irrigation, and some other potential uses. Reusing of water by installing a irrigation integration or installing it into the irrigation system, grey water collection, rainwater collection, mechanical water use. So that would be, so for example, the condensation water from the air conditioning system, and installing that also into, and also evaporative cooling towers or other mechanical systems that use water, having alternative waters being used there, and similarly for fire systems as well. Then recycle water by installing these systems, the black water system, the grey water system. Irrigation water could be recycled as well. Here's again the condensation, recovery, and other non-potable water uses. And then monitoring, implementing education programs, water reduction strategies, and various other strategies that could aid site-specific requirements. Okay, I'm going to apply this to a couple more graphically, hopefully graphically representative cases. The next one, this is not yet our case study, but the next one, don't worry about the detail. This was a fairly big development of a project of ours in Zanzibar several years ago, where we spent quite a bit of time in the early design stages to map out a water balance, to try and understand what all the consumption of water is, and try and quantify that, and what all the potential sources of water are, and how to most responsibly match a certain use to the appropriate quality of source. So for example, mapping also in a cascading manner, which are the most responsible sources to use, what are the backup sources. So this project here had very intermittent municipal supply from the grid on the Zanzibar island, so didn't really count on that as being present all the time. This was after obviously various efficiency and reduction campaigns. So this is just the water balance of what remains. So incoming municipal was one, borehole extraction and very limited borehole extraction because it was close to the ocean was a second, desalination was a third as a fallback, and then mapping that against potable needs, against irrigation needs, against toilet flushing needs. And then there was a small scale grey water recycling system from the accommodation blocks to recycle shower water, and also on the whole precinct scale, a black water recycling system to treat wastewater for irrigation needs. Okay. Then I thought these graphics were quite useful. They come from the US Department of Energy. Nonetheless, they are quite useful even, I think, in our context. What we have here is an example of an ideal building in terms of water management. And perhaps what is the most useful thing to say is to actually just at some point take these slides and study this case study here with the various water flows and the water balance that results. But this building here is obviously the ideal case and is as off the water grid, or it's totally off the water grid, and also recharges the aquifer. So it's a very responsible, more or less from a water point of view, self-contained system. It does obviously rely on rainwater collection as an input, but has various systems to treat to potable quality, also treat to non-potable quality for those uses like toilets and irrigation, and any excess is collected and back channeled back into aquifer recharge. So a very ideal case, and compared to that is I didn't change my wording, apologies. This should read a best practice case, can still be considered a net zero project if the balances work out, but is not as independent. It has the city potable water mains coming in, but produces sufficient water to offset that. So here the definition of net zero is very important. In the US context, a little bit different to ours with the Green Building Council's definition, but still a very responsible building. And yeah, the reason why I put these two slides up is to demonstrate that the difference between the two, this is considered good practice, and the previous one is the ideal case. There is obviously a whole lot of technology, a whole lot of systems that are at play, and a whole lot of site conditions that might unlock something like this, and perhaps if not there, then it might only unlock something like that, budget constraints, regulatory permissions, site space, and the like. But is to really see how we can move from, rather than what's the minimum we should do, to how much can we do on our site, and can we aim for the ideal case wherever possible. Okay, I'm going to pause briefly and see if we want to talk about any practical applications. As I mentioned, there's no silver bullets. Every case is different. And for us today, it was more about understanding the background, the tool a little bit, and some of the hierarchy of how to approach this, and then some of the practical interventions wherever possible. Any questions, any comments, any remarks on still being left a little bit in the dark, would also be welcome to see if we can unpack that at this stage. Yes, St. Peter or Brian, I think you're both on that line.
Thanks, Andre. I'm just thinking in my head, do we have any desktop modeling tools that we can use, in our desk with the engineers, where we can model and sort of quantify how much is each of those we can, either harvest, or what are the quantities that we can or possibly discharge, or how much is the potable? Apart from the spreadsheets that we now have from our metering, just to balance these as well, using those spreadsheets to say, possibly to an ExCo member, this is what we're looking at in a certain building.
Yes, so we'll be talking about a tool that the Green Building Council has made available. It's the new build water calculator or water balance calculator. I'll be taking you through a case study using that tool shortly. I suspect for your case, it's an existing building or existing buildings that you're talking about. There are also calculators that the Green Building Council has for those to help unpack the various sources and uses of water. For today, we'll be talking about the new build one, which can also be used, obviously, to apply that to an operational building, but it is aimed at quantifying what do we predict we'll use on potable water given our shower flow rates, our tap flow rates, and what kind of toilets we have, how many occupants we have. We'll talk about that tool in detail. But yes, there are also other tools in the coming from the existing building performance tool that the Green Building Council has developed. Okay, any other comments or questions? Great, then I'm going to move on to just briefly talk about a couple of tips to continue a net zero design into the operation. Oftentimes, the green building movement has been, sometimes the green building movement has been criticized for bringing about fancy, shiny, technology-heavy new buildings that run efficiently when they are new or when they are being maintained effectively, but it's easy to let that slip. So the conversation should not just end at what do we do when we do a major refurbishment or when we build a new building, but how can we continue operating at that level when that building is going into years of operation, into its running through its lifespan. So coming from incorporating, net zero into the design, reviews on new projects, making sure it's embedded. We talked about the water meters, and monitoring for leaks and operational issues. Then here we really move into preparing for the operation, develop a building operational plan, and ensure that then the building water and wastewater systems are adequately commissioned to ensure that they actually operate as intended. Oftentimes a system is operational, but not necessarily operating at ideal conditions, and that's where the building commissioning process can really go a long way to unlock those efficiencies and ensuring that the system is installed according to the appropriate quality, functionality, efficiency, can also be maintained in that way, and O&M manuals and as-built documentation is handed over effectively and training done. Then this is quite useful to keep in mind that contract language should be developed to maintain the integrity of net zero. Do we have the service level agreements on our systems in the building to ensure these systems continue operating as required? And then for the ongoing use, implement an active institutional change and training program for the occupants within the building to use the building as intended, to create awareness and encourage individuals to do their part and use appropriately. Okay, I'm going to pause again, see if there's any comments or questions before we move into the first case study or the case study of today. All right, seems like we are clear. Okay, the building's called The District. It's located in Cape Town, and it has achieved a net zero water level 2 modeled certification. It was part of the pilot projects at the time when the net zero tool was first developed, and it was certified in 2018, if I remember correctly. Yes, the certificate that we see in the bottom left here also confirms that. So I put the certificate here on the screen for you to just see what it looks like. And to also see what you can glean from the certificate about what that means. So the level is indicated on the certificate, what that includes, the occupant consumption, whether it's modeled or measured, and the validity of that certificate and whether it included any water offsets that were purchased, and it did not. It included 0%. So this is where you would see, for example, some of the net zero carbon project that I mentioned earlier that may be using carbon offsets. You would see that percentage of offsetting that project utilized in its certification would be indicated there. For now, I suspect that most net zero water projects that have been certified or will be certified in the near future will not be making use of water offsets. As we discussed, those aren't yet formalized and not really developed for use. Okay, so just a couple of points on this building. There was a fair bit of intervention to reduce the on-site demand, and then a big project regarding the on-site supply of an alternative water. So the building resulted in about 7.4, or the building consumption got reduced to result to about 7.4 kiloliters per day. And then a basement seepage water reverse osmosis filtration plant was installed that could provide up to 80 kiloliters of potable water per day. So just drawing your attention to the rather large discrepancy between the demand and the potential supply of this building, of the system in the building. And what that means is that it can comfortably meet its own needs, but also able to produce much more than the building's own use. The thinking behind that, so the developer, or the owner of this building, Growth Point Properties, thought this was implemented close to day zero, and they thought that it would be prudent to install in buildings that lend themselves for it a system that can produce more potable water than that building needs, to potentially be pumped into trucks and then trucked to neighboring buildings or some of the other projects, close by projects in the portfolio, to potentially minimize the impact of day zero water. So that was the idea behind that. There was, this is just on the left-hand side, an example of some signage that went out into the building. It was developed by Ogilvy because they're one of the main tenants in that building, and I think they ran that campaign throughout. Water efficiency interventions achieved, hard to perfectly quantify, but achieved up to 78% savings against a benchmark building. A couple of interventions, dual flush toilets, waterless urinals, low flow bathroom tap fittings and kitchen tap fittings were implemented throughout the building. And this is a photo of the treatment system that was installed. And as I mentioned, can treat up to 80 kiloliters per day. It's a reverse osmosis system, and it treats the water to World Health Organization levels, somewhat exceeding the standards that SANS requires. James, you've got a question.
I was just wondering, considering that they've got excess water, wouldn't this be a good example of one where they could sell it as offsets? I don't know exactly how it would get to whoever's needing it, whether they plumbed back into the municipal supply. But considering that it's of World Health Organization standards, it would seem that they could just put a meter on their system and sell that off.
Yeah, unfortunately, it's not quite that easy to do. So as far as I understand, the current City of Cape Town regulations and bylaws is regardless of the quality that the system treats to, feedback into the potable water network of the city is not permissible. In fact, if there is an alternative water system connected in the building's plumbing network, a so-called RPZ valve is required to be installed, reduced pressure valve zone, RPZ, reduced pressure zone valve, which prevents the backflow of any water from the building into the municipal grid. So it's in essence it does the same purpose as a non-return valve, but is not foolproof, but is fail-proof, and stops the flow coming backwards. And if it malfunctions, it dumps the water. So that's how where a non-return valve would, if it's stuck, for example, it might contaminate. So anyway, the municipality, for good reason, is very sensitive to water being fed back into the grid, because even if the system at design and initial operation operates at those standards, quality standards, they are concerned that it may not indefinitely and could in the future contaminate the water. They also have various other requirements that if you produce your own water and consume it for potable uses, you have to do regular testing of that water. You have to get certain licenses, water use license and water intermediary license. So in essence, taking the municipality's place, even if it's just for that building. So the regulations are quite tricky and was one of the obstacles in delivering this project, because we had to navigate those as not many buildings had done, I think, and the landscape was changing, because obviously there was a big focus during the height of the water crisis. So unfortunately, not quite that easy to respond there, James. It could potentially be trucked, and that was the aim there, if really the pawpaw hit the fan, if you will, and day zero hit, but plumbing it into the municipal grid wasn't allowed, isn't possible, and obviously running a separate pipe over urban boundaries also not easily, or as far as I understand, not allowed either. So theoretically, there is water available for that, but practically implementing something like that, unfortunately, somewhat complicated. Does that give some context there, James?
It does. Thanks, Andre.
Okay. I thought I briefly saw a hand up as well. Is there someone else that wanted to respond or ask?
Yeah, hi, Andre. It's Mary-Ann here.
Hi, Mary-Ann.
In the definition of the net zero, it says all water produced by the project must be reused.
Yes.
What happened with this? Or is it that the water would have been pumped into the stormwater anyway, or the sewage network anyway, because it was basement water? What happened there?
So you're onto two good points there. The first one, I'll address first, your second one. The reason why the water balance worked out for the site is because more than 80 kiloliters a day was extracted from the basement seepage and pumped to stormwater to dewater the basement. And thus, by extracting up to 80 kiloliters a day, the groundwater around the site was not worse off. So that's why the system was allowed. Also, the various other requirements that I had in that table earlier for basement seepage water were met. Regulatory compliance was ensured, and that's why that one was met. So to your first point, where you said all water produced has to be used, the certification pursued was just a net zero certification, speaking to covering the building's own use with the system's capabilities. So while it had the ability to generate up much more than the building demanded, the certification was based on only meeting the 7.4, 7.5 kiloliters a day that the building required. So we didn't need to demonstrate any further use because we weren't aiming to certify a net positive building.
Okay, that makes sense. Yeah, that makes sense. Thanks.
Great, Simpiwe.
So thanks, Andre. So certification, does it mean that I do not need to obtain a license to reuse internally if I'm certified at level 2?
No, you would have to. So the water use intermediary, I think is the name of the license, I speak under correction. You would have to obtain that from the city, depending on the orders of magnitude and in any other triggers. You might have to obtain a license from the Department of Water. So that would have to be done, and is in any case to be compliant and allowed to operate this according to the municipality or national laws. But also it is a check and balance in the submission for the building net zero certification that those requirements have been met. So you would have to meet those requirements. I'm going to briefly just jump back to the table that we discussed a little bit earlier. It's quite far back. Here we go. So this is the case that we pursued for this project. The efficiencies were there. Metering of the extracted amount and also within the building was met. And here is that nuance that I just discussed after Marianne's question. The extraction volumes after the certification project has been implemented to equal.
Hi, can everyone hear Andre?
No, we can't hear him. Oh, I
Sorry,
can't.
Andre. I think you lost network. I will send you a WhatsApp, but we can't hear anything.
Okay, give me a quick second. Oh, am I back?
Yep.
Yes,
can you hear me
thanks.
now? Right, apologies for that technical glitch. Just in case, I'm going to keep my video muted for now. Right, where was I? So yes, so this is an important nuance here that we are not allowed to, in order to pursue a certification, extract more, even with an existing groundwater seepage system, to achieve the certification than we did beforehand, and that was met because the basement was being dewatered. More than 80 kiloliters a day were being extracted, pumped to stormwater, and ran quite quickly to the ocean. So the water table was no worse off by implementing the net zero project. Then a seepage water management plan was developed and implemented for that building, and we also provided evidence that all the required quality standards plus municipal and national regulations were being complied with and met. So I hope that answers, Marianne, all of your questions, and also simply were yours.
Thanks, Andre.
Okay, then a little bit more about that project. So it also achieved, separate from the net zero certification, also achieved a 4-star Green Star existing building performance certification in 2016, so roughly 2 years prior. And I believe it's been recertified since. I was not involved, but I believe that's part of Growthpoint's ongoing recertification campaign. A couple of the achievements under that 4-star certification are listed here. Not really the point of today's discussion, but just wanted to also highlight that water is a very important thing to consider in a building, but shouldn't be the only thing. So we were very happy to work on a project that had already done good work for the sustainability principles of green building interventions on a bigger scale. A couple of obstacles that we encountered. So at the time of pursuing this project, the definition of what an environmentally sustainable water source was not nearly as defined as it is now. So various so-called credit interpretation ruling submissions to the council were submitted, and those were internally discussed, but also externally with industry experts to make sure that opening up a new definition or new pathway to pursue net zero water didn't have any of those adverse effects that we talked about earlier, and was legitimately to be seen as a environmentally sustainable source of water. So that was quite challenging, obviously time and effort well invested, but was quite a time anchor, if you will, slowed the project down. So it was a fairly challenging process, but as I mentioned, in the end, I think a reasonable balance of updating the definitions was achieved, and aided projects that had those nuances that could be pursued for certification like this one. Then it became difficult also because it was the first one to claim basement seepage water, so not just the definitions, but also how would that, from a methodology point of view, be seen in the eyes of the tool and the various calculators, if that's to be used as an alternative water source. So a little bit of figuring that out was needed, and also difficult in a multi-tenant building to have to engage with on their various appliances that are under their control and not under the landlord's control. So the existing building performance certification, just focusing on water, we took that a bit further and engaged with all of the tenants in the building to do what they could to reduce their water consumption, even if outside of the control of the landlord. Okay, a couple of project wins. Saving municipal water, especially during the Cape Town drought, was a huge achievement and a big win for the project. Future-proofing the building against future water stresses. The filtration system, as I mentioned, is oversized and therefore allowed for more than 90% of its capacity to be used elsewhere, in neighboring buildings or other growth point buildings in the portfolio nearby. Then tenant engagement and retrofitting the tenants' taps for the certification, but obviously affecting water savings for them and for the building and for the Cape Town network as a whole. Reduce stress on the wastewater treatment system, sewage treatment, as a result of less water consumption. And then water is also now used and not pumped straight to sewer. I speak under correction, actually. Right now, I'm sorry, I'm actually not 100% sure whether the basement seepage water would have been pumped to sewer or to stormwater. This point here makes me think it was sewer, but my previous points, as you know, I said stormwater. So I'll just double check what we actually did on that project. Nonetheless, it took pressure off either the sewage system or the stormwater system, which is a project win. I'll just double check that. Then occupant engagement and education through informative signage throughout and open displays of the treatment plant in the basement that someone could, passers-by might see it and then engage on what that is and talk about the whole principles and systems intent as a result of that with other occupants. And then overall contributing to demand-side management for the City of Cape Town's potable water network, especially in the height of the drought where it was implemented and launched. Okay, any comments or questions at this stage?
André, you're Brian, yeah. Do you think in hindsight, if Growthpoint could do the project again, would they put in such a big reverse osmosis plant, or do you think they actually overspec'd it?
I can't really speak on their behalf. I have a feeling they may oversize again, but perhaps not as much. It turned out not to be needed because, as we all know, Cape Town did not get to day zero, and it wasn't needed to distribute that treated water to other sites. So perhaps a overcapitalization there and perhaps a lesson learned. And I suspect, but I really don't want to speak on their behalf, that next time they might oversize it to some extent, but perhaps not as much, yeah.
Yeah. Okay. It's interesting. Thanks.
André was wondering, do they have a municipal connection in case seepage water reduces in future drought scenarios?
Yes, they have kept. So this was an existing building, and the basement seepage water was, as I mentioned earlier, already extracted and pumped off. So the existing municipal connection was maintained, and the building switched over to the alternative water, treated water at the time of it being commissioned, but also maintained all the connections should that dynamic change. I don't foresee the seepage water, all of a sudden becoming 90% less and not covering its own needs, but also for times of the system being down for maintenance, or should, for example, a regulatory compliance lapse and be drawn out, they would have to switch it off and use municipal water until that's all restored. So the municipal connection really is a redundancy measure and allows for flexibility in how that is operated, that plant is operated. Okay, any other questions on this case study? Great, then we're going to move into the next phase of today, which is the demo. I have a feeling that we'll be finishing a little bit ahead of time. Don't want to preempt that, but I'm not going to talk about the demo for 40 minutes, so please feel free to ask detailed questions on this or also on anything else. We'll have some more time to discuss the demo and the calculator, but also we'll have some more time for Q&A of anything and everything that was discussed today. So yeah, what we're looking at here is just some of the input metrics or metrics for the building, which serves as inputs into the water balance calculator, which I'll call up in a moment. I've just put a screenshot over here of some of the results that come through, and then the end results, which demonstrate this is the net zero building, the reduction versus the notional building of 100%, which indicates if 100% has been reduced, then we have arrived at a net zero outcome. So please bear with me while I just call up the calculator. Trying to navigate my multiple screens. Okay, here we go. Okay, can you all see the Excel?
Yes.
Okay, so this is, I think, also in the material that Gretchen and Tumeka have made available. It is the so-called PEB water calculator. PEB stands for Public and Educational Building. It's one of the new building tools that the Green Building Council has available. And if you look at the tabs at the bottom, it covers all of the various categories and credit categories that that tool covers. We're specifically today talking about the potable water calculator over here. And the aim of that calculator is to predict for a subject building what the water consumption may be, how much could be captured in a rainwater harvesting system, how much could be offset from total consumption by alternative water systems, like the one that we just talked about for the case study. So I put onto the slide that you just saw the input metrics, and what we'll be talking about now is just running through where that would be entered into this tool. It is obviously a specific case study, so please, when you use this tool for your own project needs, apply your specific metrics, your specific cases to this. That is appropriate, and you can use the output data accordingly. So there's a little bit of a navigating bar at the top here where you can jump to the various sections of this tool. We'll just scroll from top to bottom for what we need. If this were to contribute to a new building certification using this public and educational tool at 12 points, which is the maximum available for potable water, would be achieved. And as I said earlier, the outcome is also here to demonstrate the net zero outcome. Okay, so the first order of business is we would just define the various space types. In our case, it's office that has 1,000, estimated to have 1,200, or capacity to accommodate 1,228 occupants. So this is just my name for the space. Here's where we define that space, and you have a drop-down of various types of spaces that are available. This public and educational tool is very useful that it can take multiple different typologies at the same time. Some of the other new build tools do not, and that's why we're using this tool today, even though it is only an office building and could have used the office calculator. It is the most robust and dynamic water calculator that the Green Building Council has at the moment. And if you are to do some investigation work for a potential net zero certification or for just best practices, I suggest using this tool for the most dynamic approach. Okay, the building operates on a 5-day a week typically, and we assume that all of the occupants have access to a shower in the building. We'll define just now to what extent shower water or showers are used, and it's a mild usage. I'll show you where. Then where's the site located? It's in Cape Town. Automatically the zone, the climatic zone, is then populated, and rainfall data, both in terms of quantity and also how frequent, is populated by this tool. So this is all kind of pre-programmed in. You don't have to go and collect this. Water demand is the next very important section that we have to define. So in the slides, I gave you all of this. So if you want to recreate this at some point, you should be able to. There's 2 different types of toilets, some that have dual flush. 99% of the toilets actually have dual flush. It's a 3 and a 6 liter flush, and there's a calculation to arrive at a single average flush. It comes out at 3.6. Second type of toilet is 6 liters per flush. Only 1% of the toilets in the building use that. That then arrives at a certain actual building predicted consumption versus what a notional building is predicted to that it would consume in its stead. Are there any urinals in the building? They are indeed there, and there are waterless urinals. All of the urinals are waterless, so you can see the pattern here again. What do we predict the actual building to use for urinals? 0 liters or 0 cubic meters per year, because all of the urinals are waterless, versus what a notional building would consume. And so it carries on. The kitchen taps at 6 liters per minute. 3% of all the taps in the building are those. Then we've got some manual taps in the building that consume 0.6 liters per minute. 85% of the taps are that. And then we have some that are automatic with passive infrared sensors. They also use 0.6 liters, and 12% of the taps use that. So this is the only input data for all of our consumption that we have to put in. And the calculator works out what one could anticipate being consumed in the building, given the uses of water and the amount of occupants and the space types. So similar for showers, there are 7 liters per minute showers. All of the showers are the same here. And then just what kind of shower use. There's no significant gym or cyclist facilities in the gym, in the building. So what that basically does, the calculator assumes a much lower use of showers than it would if there were a gym, and more heavy use could be in place there. Okay, good. So here's an overview of the building's consumption in comparison to the modifications in comparison to a notional building. So you can already see that the building is much more efficient than a notional building because of the various low flow interventions that have been done, graphically represented over here, broken down into the end uses, showers, taps, urinals, and WCs. Okay. Could be a useful exercise to recreate a existing building, one of your existing buildings in this calculator, and then if there is sub-metering installed, seeing if that is roughly accurate, and then managing it from there. Okay, the building is air-conditioned, all 18,000 square meters of it. It is air-cooled chiller, so we don't have any evaporative cooling water requirements here. So this section would all be zeros, but if it was water-cooled, this is where you would define that. And just to also double-check that there's no other non-cooling tower heat rejection devices or demand. There isn't any. They're all, I believe it's all split units in this building. No, it's not. It's chillers, but they're air-cooled chillers. Yeah, that's the system. Okay. So a summary, but because there is no heat rejection, all zeros, and so we scroll through. There is no irrigation demand on the site, but this is where you could also define your different types of landscaping and the requirements, and that will be matched against the rainfall and irrigation schedules in here. So quite useful to also calculate one's irrigation demand and how that relates to anticipated rainfall in that region. Then one can input swimming pools. For our case, that's not applicable. Any other major water users, if there's, for example, a laundry, that would be entered here, or a large kitchen, that would be entered here, or any other major uses. So the tool is flexible enough. If it's not one of the typical ones that we've just listed above, one can also activate the other section and populate the detail of those uses in here to account for all the significant water users in the building and get a full picture of the water balance as a result. We don't want to not look at any simply because the tool is limited. So that's why if there's any others, the tool has the flexibility to accommodate them here. All right, so here's a summary of the demands in the building. We've only got the typical office-related ones. You can see heat rejection, irrigation, pools, laundry, etc., all at 0. And green is the actual building, and the darker maybe even brown, darker olive green, perhaps, is the notional building. Okay, this is for the end users, split into end users, and this is into monthly. Right. Then sources of water, sustainable sources of water. So we know that there are any, or are some. It's not any grey water, black water, or swimming pool backwash systems. So that's why that is a no. So zero recycled water demand is no rainwater harvesting. But here we come again, the tool is flexible for the non-typical other sustainable water sources. So this is where we would input that here. The way I've input that is I've added the system's capabilities, 80 kiloliters times per day, times by January's 31 days. Similarly for Feb, 28 days, March, etc., throughout the year. So this is what the system can produce. Oh, made a mistake with June, apologies. This is what the system can produce. And now we match the capabilities of the system to the demands that we mapped earlier. And we are saying potable quality, therefore, all of the uses that we've identified are covered by the system by 100%. Okay, I hope that's clear. So here we're doing a balancing act, a mapping. What uses do we have and which sources cover that? Hope that's clear. Okay, great. This is where one could also add rainwater, grey water, but for our case, it's other sources that's mapped over here. All right, and then we have the summary, the outcomes. For if it were to pursue a Green Star certification, here's the point allocation from 0% reduction, 0 points, all the way to 95, 12 points. In our case, we achieve 100%. And that sets us up for a net zero water certification. Good. I'm going to pause at this stage and see if there's any questions on this tool. I personally am a fan of spreadsheets, but I do know that a new spreadsheet, especially one that's quite large, lots of little toggles for yeses and nos, and what type of systems can be overwhelming. So please, by all means, feel free to ask any questions. Seems like quite a bit of silence out there. No questions.
Sorry, Andre, it's Imperial here. We're
please.
just wondering, how do we get access to the modeling tool? Is there a payment or a fee for
As
access and use?
GBCSA members, can we get access to it?
So I speak under correction, but I think it's in the, I haven't looked yet, but it's in the course materials. So through being attendee, you will get it. Maybe Gretchen, if you could speak up on where exactly attendees can find it right now after the fact.
Correct. We will send up a resource pack to all of the attendees after the webinar, and it will include the tool.
Maybe just a quick question then into the room. Would you like it to be the version that's pre-populated with the case study, this one that we're looking at on the screen here, or the blank one that a typical project would receive should they pursue a certification?
Both is fine.
We're going to be demanding. Can we have both?
Yeah, both is going to be okay.
Gretchen, I hope that's okay with you. If
That's
you can make both
fine, no
available,
worries.
I'll send you a copy of this one, and then obviously you have access to the standard one from the PEP tool. Great. Very pragmatic question, good question. How can we get the tool so that you can make use of it? I personally quite like this tool. It's quite flexible, as we discussed and saw as we went through, and is a useful way to see where we are at with balancing our use versus our various sources. Does anyone have any reflections on the tool? Can you envisage making use of it? on your existing infrastructure, on a new project coming up?
Andre, are you aware of comparisons between the tool's predicted water consumption and actual measured water consumption of buildings? Has that been investigated?
I am not aware, James. It's a good question. And maybe, Gretchen, if we could take that up with your colleagues in the certification or technical department to see if there is any. But just theoretically, to respond to your question, James, there will invariably be differences, and potentially fairly big ones, because this is a model, and any model is only as useful as its assumptions and inputs. So quite understandably, when this tool was developed, the various relatively blunt assumptions had to be made to link occupancy patterns over here against specific devices over here and arrive at a number of water consumption demand, as we can see over here in this table over here. And in here is probably the biggest suite of assumptions, mapping that out. And I'll be quite keen to see comparison, but it is so project specific. You know, a project may be quite close because the occupants happen to behave similar to the assumption in the tool. And then you could have a building where there is a bunch of hyper aware, very progressive eco warriors, if you will, that you know, try and save every single drop of water, and all of a sudden this tool might overestimate. So it is really quite dependent on the occupants, and that's why we talked earlier in the presentation, why in order to ensure long-term efficacy of a pursuit of a water efficiency campaign or even a net zero outcome, the occupants are a key stakeholder in that program or in that pursuit. Okay, I see two more questions. Sandre, sorry, pronunciation there. Say Growth Point, we're rating another building and not this one. Could they claim this installation as an offset? Obviously, assuming they cannot later rate this building. Tricky. Indeed, quite tricky, Sandre. I don't have a clear answer for you. Maybe I need to think this through and discuss that also with the Green Building Council. The difficulty I see is on an ongoing basis, making this water available to another building, and the potential regulatory challenges that the City of Cape Town may implement in this case, or any other municipality for that matter. And also, I don't think it would qualify as an offset, but rather as an offsite solution. So pathway 3 rather than offsetting would be pathway 4, if we can just think back to that first inverted pyramid that I showed you. But yes, there's a potential case to be made here. I'll discuss that with the technical team and see what the first view is. Yeah, if I'm hoping that you're speaking about a potential actual project and invite further dialogue on that. André, thank you. Any responses there? That was clear. Then Edmund, thanks for your question. Does the notional building predicted consumption consider municipal bylaws? I think at the time of this tool being developed, there weren't specific bylaws taken into account. So I think the answer is not bylaw specific, but rather typical device and occupancy patterns are considered. So it's more of a typical consumption. If we were to include irrigation demand, then that would be relative to the climatic conditions, what is typically required there, and also what location-specific rainfall can be anticipated. But I don't think it is as specific as consumption according to bylaws. And I'll double check that with the technical team and get back to this forum, rather to the attendees if I am mistaken there. Okay, Sandra, thanks. I see you noted there that I hope the question's answered, but your audio isn't good. Okay, great. Any other questions or comments at this stage?
Sorry, hi Andre. So I wanted to ask about cloud seeding. What do you think about cloud seeding?
It's a very interesting conversation. And perhaps not suitable for this specific focus. My opinion is I am withholding an opinion is actually what I want to do. I'm not informed enough about that practice to give a meaningful answer. I think it can play a vital role in some very water scarce regions, but I am aware that it might have some unforeseen dire consequences. The recent flooding in the Middle East a couple of months ago was, according to some, linked to perhaps irresponsible cloud seeding. I don't want to venture whether those headlines are correct or not. I don't know enough, but I think it may have very drastic consequences. And then also something like that is not site specific. So it would be very difficult to link our specific sites and net zero targets to that practice, which is done obviously on a regional or city scale. And can we count on it? I suspect not. So I wouldn't factor it into this balance.
I was asking in the context of the slides that you showed, showing the data, what we're looking at over the next 100 years, you know, and just on a bigger scale. But there is consequences to cloud seeding. But I'm sure with more developments, I hope it can be something, you know. But that's all. Thank you.
Thank you. Also, a good question. Adil, you've got your hand up. Please go ahead.
Yeah, thanks, Andre. This relates to a project that we're currently working on. So we're looking at the groundwater recharge aspect in terms of achieving a net zero, net positive site. We mentioned earlier that when we recharging the borehole or an aquifer, we can't sort of confirm that that water is staying on site. Would that then also be considered as the water like crossing the earth line or property boundary if that basin or that aquifer can't be proven that it's only on site? Would you then need to get some sort of municipal allowance as well?
I'm afraid, Adil, that I am not familiar enough with those dynamics to give you a good answer. I think, and this is also what the Green Building Council encourages, that perhaps at this stage, the services of a hydrologist are needed. I'm just going to refer you back to this slide over here. So I'm not sure if you're linking that to borehole extraction, but either way, the Green Building Council encourages innovative ways to recharge the water table and at the same time the hydrosensors and a water balance. So this is what I'd like to refer you to, is to ensure you have good advice and see if what you're planning to do with the recharge is responsible and is related to the abstraction that you have in mind, perhaps through borehole extraction, and engage with the Green Building Council. They are very eager to receive projects that are pushing the boundaries here. And perhaps, I don't want to put any words in the technical team's mouth, but perhaps they would even unlock it as an environmentally sustainable source of water if it is linked to appropriate and direct comparable recharging. Please don't quote me on that, but I would like to encourage in any case to engage with them, to explore, and maybe there's an opportunity here.
Yeah, no, cool, will do. I think, just to give a bit more context, so we're like aiming to use the borehole as a last resort, sort of a lesser evil in times of scarcity. So instead of opening your tap and connecting to municipal when you don't have the water, you like use the borehole water. But then obviously you're going to need to sort of recharge that. So yeah, I guess opening the conversation up would sort of lead to different avenues. Yeah, cool.
Yes, I fully support your set of priorities. This is also how this table was developed, is the least responsible is treated potable water that's in the network subject to leakages, etc. Don't try and avoid using that. And instead, rather than, as you rightfully said, instead of relying on that, can we have another redundancy mechanism if we don't have enough from other sources? And borehole would be typically wiser than just resorting to potable municipal water. But is that sufficiently responsible and well considered to be deemed part of a net zero water strategy? That's where I'd like to encourage you to specifically open up the conversation with the council. Because at the moment, as it stands, the answer is no. Can't use the reliance on borehole as your last resort as part of your overall water balance. But asterisks, please chat to us is really what I'm trying to say.
Yeah, cool. Will do. Thanks.
Excellent. Any other questions? We'll just open up the calculator again to see if there's any questions here. This is also the last content. The second to last slide is just some resources. So when you get the slides, please do look there. I found them very helpful in my research. Leading up to preparing for today, I also found them very helpful over the last few years as good tools to use. So there are hopefully there's some nuggets there for your use. No point in having that slide up now because it's just a list of links and publications. And then the rest of the time was really aimed at Q&A. So please, now's a good time to ask any remaining questions. Andre, you are asking, do you know of any available public water balancing calculators other than this tool? I'm not familiar with any very useful ones as we speak. No, I think is the fairest answer at this point in time. There are some very useful water risk calculators that the WWF has produced that I've linked in the additional resources. Those are useful to just assess one's water risk for the basin, for the region, but not water balance calculators, no. I haven't specifically looked for others, to be honest. So, yeah. Any other questions? Oh, here's another one. Thanks. Oh, right. That's another question. Oh, I see in the attendee list that there are a few technical team members. Michael, so I thought I saw Emma just now. Oh, I don't anymore. Yeah, I'm gonna also chat to them about some of the topics that we discussed. Michael, if you can take a note of that, please, that we engage. Okay, it sounds like we are out of questions. Oh, I do note that there are 3 attendees that have not got a microphone next to them. Gretchen, if you can just maybe afford Nandi, Vimal, and Sondre the option of speaking if they would like to still pose a question. I think, Sondre, that's the reason why you weren't able to answer earlier. Your microphone hasn't been enabled. Thank you, Gretchen. Sondre, you're there. Was there anything further still? You did respond in the chat. I think all clarified, but anything you would like to add?
Hi, can you hear me now?
Yes.
That helps. No, thanks. Thanks for your clarification. That helps. I did have a rather random other comment. Have you sort of an issue around how do we, I don't know, allow property managers to take seriously net zero into operation? So, I mean, a silly thing that's like a personal bugbear, that when you walk into a commercial facility and perhaps use their bathrooms and notice that the dual flush option doesn't exist, you know, so they go to all the effort to install the fancy Geberit dual flushes, but you can't do a half flush, use a half flush on their system. So, I mean, that seems to fall apart in operations with small things like that, or even aerators being removed, that kind of thing.
Yeah.
Yeah, I don't know if you have any comment on that.
Besides that human nature is sometimes
Yeah.
our worst enemy and resorting to the path of least resistance. It is obviously difficult if you're on the cutting edge of efficiency to maintain all those systems.
Mm.
And even if it's simple things like the half flush is not functioning, speaks to maintenance. South Africans are also unfortunately not the best at maintaining the systems that we do build. So it's kind of a dynamic there. I've got no specific advice other than a good metering and monitoring and analysis of that data that one can see, okay, month on month, we're using more water, or year on year, we're using more water. There's a trend we need to investigate, something that brings that to the high level individuals' attention that make these decisions rather than relying on maybe someone from the cleaning team alerting maintenance to it, or expecting maintenance to walk through every bathroom and picking that up themselves. Data oftentimes lets issues bubble to the top and decision makers to then initiate action. And I briefly mentioned earlier also just a plan for how the facility is to be managed and maintained can be very useful in ensuring that those gaps are found and then plugged. But yeah, no silver bullets there also, I'm afraid.
Mm. And that also brings me to, metering of water seems to be second to energy in a big way, that people will, facilities that might be doing energy metering will not necessarily do detailed water metering. Do you find that
I
as
found
an
the
issue
same.
as well?
Yeah, absolutely. Yeah, I think I can link it back to the relative low cost of water. It has historically been,
Yes,
in my mind, too low and therefore easy from a financial point of view to squander it. So that's perhaps why it hasn't been historically metered. Water meters aren't cheap, but I think with the rising cost of potable water, hopefully that'll justify the case more and more to do suitable sub-metering. Also interesting that only during and again, I'm referring to the Cape Town case, but I think it's similar, during the height of the water crisis a few years ago, up until that point, sectional title developments or apartment blocks, for argument's sake, didn't require water metering for the individual apartment, and only bulk metering. So then you've got another conundrum, which I guess you can summarize as the tragedy of the common, because everyone is collectively paying for the total consumption. Well, that's not true, but I'm just sketching the case. I love to bath, and therefore I'm going to bath every day because everyone's going to help me pay for that water for my daily bath. Just a little disclaimer, I don't actually like to bath, I get uncomfortable. Nonetheless, that is obviously a scenario that may arise, and the tragedy of the common in water consumption is particularly pronounced. And then, another dynamic, maybe I'm overstepping my boundary here, but I do believe there is a dynamic in especially more affluent neighborhoods and groups in society where they believe that because they can pay for a lot of water, they deserve to use a lot of water. And that's also another difficulty to try and create awareness around responsible water use and water stewardship, and only really taking what one needs rather than what one somehow warpedly believes one deserves.
Yeah. I hear you. Thank you.
We're nearing the end of our time together this morning. That is all I wanted to talk about specifically. So I'm just going to pan to my last two slides. This is, whoops, here we go. A bit of an overview of some of the links that I found quite useful. Please do go and work through those and see if anything is of use to you. And then, yeah, any last questions before I close?
Thanks for a very useful session.
Glad to hear that. You're most welcome. Thanks for your engagement. That really made it much more useful, I think, for everyone. Good. Thank you for joining us. And I think I'm going to hand back to Gretchen to, I don't know if there's any parting words from your side or if there's anything that you need to draw the attendees' attention to. But from my side, thank you very much, everybody. I enjoyed the time with all of you, and thanks for your robust engagement and input.
Thanks, Andre. And thanks to everyone for your engagement. I have two quick announcements, and I'll keep it very short. I think we've already touched on the resources that we will share with you later today. So that's been finalized. I think in addition to that, we are also adding a register to those of you who are registered with SACAP or EXA for CPD points. So kindly populate that register accordingly and send it back to us. And then with regards to upcoming training, our part 2 of the Net Zero Insights will be focused on net zero ecology. We had a date scheduled for August. However, we've had some internal changes and we will announce the date with you sometime next week. So please keep an eye on our social media. We will also send a mailer to all of our subscribers. And then lastly, I would also like to share a little bit of information with regards to the EPC webinar that's coming up on the 7th of August. Maybe just a quick one that may be of value to all of, or to a lot of the delegates that we have on the call. There was a call made by the DMRE for registration of professionals to issue EPC certificates for buildings. So in the past, the inspection bodies were only available to register for, to register as an inspection body was only available to organizations and companies. But there has been a change since the beginning of this month, where the SANEDI now allows individuals to also register as professionals to issue EPCs. There's an upcoming training on the 24th and on the 30th of July that will be hosted by SANEDI. Please check their website. And this webinar is really just to explain the registration process to those of you who are interested. And then thereafter, on the 7th of August, the GBCSA will host an EPC workshop to everybody who is interested. Please check our website and keep an eye on our social media for more information. And yeah, that's really all from my side. I trust that this was a very valuable and insightful session, and I do hope to see and to meet with all of you again sometime soon. Thanks.
Thank you. Bye-bye.
Thank you. I'm ready to close
Thank
the
you.
call. Bye, guys.
Thank you. Thank you.
Thank you. Bye.
Thank
Bye,
you.
everybody.
Thanks,
so much.
everybody. Bye.
Bye.